Slides are coming momentarily.
Unusually slow. Oh, that's not a good sign. Something happened to Eric?
Hmm.
Meet echo, how we love thee. All right, do that one more time.
Did it just kick you out?
Oh yeah, fully.
Sweet.
From the entire room. Back to the agenda. All right. Does that look like slides?
Didn't like your slides. Your choice of font, I guess.
It would be the choice of font. Does that look like slides?
Yes.
It does.
If I make slides big, does it still look like slides?
Indeed, it does.
Mhm.
That's
Yeah,
so
it looks good.
Great.
All right.
All right. All right, so we can get started. Thanks everyone for joining for the final session of this IETF. This is the Masque working group meeting. Eric, can you please advance? Perfect. As you all know by now, this is being recorded. We're following the sort of usual process for participating and engaging in the meeting. If you haven't used the Meet Echo tool before, some instructions to interact with it are here. If you want to say something at the mic, you queue yourself up by pressing the little hand icon, and then leave by also pressing the hand icon, but in the opposite direction. You need to make sure you explicitly send your audio. Otherwise, we won't hear you. We'll just be asking you where you are and what's wrong with your mic. It would be helpful to the note takers or to the note taker and scribe if you could state your full name at the mic, just so we can get everything down the record clearly. Next slide, please. This is the note well. If this is not your first session for the meeting, you may have seen this before. Just like to point out the code of conduct. Please be respectful to everyone here and of their perhaps differing opinions. We've had no issues so far, and I don't expect we will have any issues. But just let's all be nice. Next, please. Some helpful links in case you're following along at home with an actual local copy of the slides. You can pop in the CodeMD page if you're interested in helping with notes. We'll get to the notes in just a second, or in Jabber, and we will get to Jabber in just a second as well. Next slide, please. Right. So before we can go any further, it'd be really helpful and great if we could have a scribe or note taker to help us keep track of things that transpired today. So if someone could volunteer for both of these things, that would be very lovely. Robin says he can scribe. Thank you. To clarify, do you mean Jabber scribe or note taker? Note taker. Okay, great. Is someone willing to be Jabber scribe? It's very, very simple if you're in Jabber.
I'll do it, Chris. This is Lucas speaking.
Thank you, Lucas. All right. So we have a couple of presentations on deck today. Connect UDP from David, IP proxying requirements from Dallas, quick-wire proxying from Tommy, and some additional IP proxying requirements from Miria. We also have an update on the interop that happened last week that Lucas is going to present. Before going into this any further, I want to pause briefly to ask if anyone wants to bash the agenda or make any adjustments. Tommy?
There we go. So just a quick bash, not required, but if we look at the presentations, while they're grouped right now by like what's adopted and what's not, topic-wise, we have 2 documents on connected UDP and 2 documents on proxying requirements. And it may be a little bit less whiplash and better for the conversation if we can talk about them together. If that's okay with people, I don't know if people have objections to
that. From my perspective, that seems quite reasonable. I'd like to at least avoid context switching as much as we can, given the hour of day for most people. Mary, the proposal was to lump together the Connect UDP presentations and then lump together the IP proxying requirements at the end. Yeah. We have 1 person opposed. I guess let's just stay with what we have for now. If it's not unanimous, might as well not change it. All right. On that, we can pop over to the interop report.
Alex is also in the queue.
Sorry? Oh,
Alex is also.
Alex, please go ahead.
I just wanted to mention that Dallas isn't able to present, so I will be presenting IP proxying requirements.
Oh, thank you.
Thank you for covering for him.
All right. Can you flip over to the interop slides, Eric?
Indeed, I can.
And Lucas.
To do our little song and dance, switching windows.
Sadly, I don't have a Masque logo to make a hat with, so just a request to consider for next time.
Not a
A
hat.
mask. Oh, I got a clown one, and I don't think people will like that. But anyway, Masque interop. Yes. So having convened the Masque working group, I think, well, personally speaking, as I've been really looking forward to doing anything related to tunneling something in Quick for a few years now. I know David's been kind of working on lots of ideas and stuff in the background, but I never had a chance to really sit down and kind of play with implementing this. So I was super excited for an interop. Next slide, please. So during the hackathon, some of us have been doing some interoperability testing for Masque. So what we have is a nice kind of a bit like the quick interoperability matrix, but different. And this page is hosted by Tommy on GitHub. But what this is, in a nutshell, is a presentation of some of the requirements taken directly from the document, alongside some implementations that have been trying to do interoperability. So I might let Tommy talk more about how this was all generated, but effectively the list of requirements is pulled out of the documents by some magic, and then the checkboxes or whatever symbols on the right hand side is manually populated here. And so we could go into each of these. I don't think that's important myself. It's good to see green. Yes, we've got an ability to see if things are being failed or if a feature's not even supported, etc. But for me, the important stuff was that I kind of look at Masque as being both connect method being used in Quick, which isn't strictly true, I know, so I apologize, but that's how I look at it. So connect method, connect UDP in this quick aware proxying thing that we'll get onto later on in the session. But what I did during this hackathon was to take Quiche. We recently landed Datagram support into the main line, and so I forked off Quiche and tried to build Masque on the top of that. Just doing self-tests to start with on localhost, and then during the course of the hackathon, I put up a public test server and had Tommy fire things at me and see what worked or not. So that was quite fun. This view is just the requirements of Connect UDP. There's a lot of green there. Connect UDP is simpler. If we go on to the next slide, please. You see there's this quick aware proxying with more requirements and less green. That's the summary I will give to that. I don't know if this is the best way to grok what happened in terms of success for an interrupt. What I'll say is I measured success by tunneling HTTP3 within an HTTP3 connection. So having a Masque client and a Masque server speak across the internet to a web server across the internet again, and without any substantial changes to our quiche transport library or HTTP3 implementation, I was able to get that done. So it identified some kind of gaps, things like HTTP3 setting that I'd forgotten. So that was good. I think that is reflected in this chart, but if not, we should get that kind of thing in. And yeah, that's kind of all I've got to say on it. If anyone wants to do some more interrupt, even though the hackathon's finished, I'll be continuing to run that server on the internet, but it does effectively act as a relay to any other site on the internet. So I've got some access control there that I'm using obscurity for my security model. So let me know.
Chris's mouth moved as though he were saying David, but well on mute.
Out of the queue and to talk. So thanks, Lucas. This is really, really cool. So I just wanted to add that and by which I mean the Google implementation, is not on this matrix because I was planning on getting it done last week, but other work priorities got in the way, because such is life. But I'm proud to announce that I got it working a half hour ago. So I got Connect UDP working with myself. But anyway, all that to say, I want to echo what Lucas was saying, which when you already have an implementation that supports H3 and datagrams, it was pretty straightforward. The only modification in the core stack I had to do was some tweaks to make sure that like some server request handler could handle requests where the fin bit was set, like connect or connect UDP, because that part of our code didn't support that yet. But apart from that, everything worked. So I'm going to try interrupt with your server sometime next week, Lucas, when I'm going to clean up the code first, because this was like completely a crash land half hour ago. Yeah, thanks.
Cool. Just to respond, I know this is maybe detracting slightly from interrupt purely, but the complication I found with the implementation, I was able to do all this in my application code, but I needed to rework the application code to consider effectively recursive connections. So, a quick connection that could hold a quick connection. And that was, like, for me, the hardest part, really. For somebody like a browser vendor or a client vendor who already has that model for HTTP proxying anyway, I could see how like Masque could be more of a direct drop-in replacement there.
So what I implemented so far was kind of like quick. I didn't actually do the work of plumbing it into the Chromium proxy layer, but that shouldn't be like overly hard. Specifically, like you said, like there's already code that handles this, so it's just a matter of plumbing. So hopefully I'll get that done soon if time permits.
Great, Tommy. Do you want to tell folks how they could potentially update this interop matrix as results emerge?
There's more to the list, but effectively, you can just create a PR with a JSON file that defines your particular implementation, and you just list kind of Booleans for which features worked or didn't, and then those features kind of know how to annotate themselves as like, oh, that's really bad or that's good.
Thanks. Lucas, unless you have anything else, I think we can move on.
I had a final point. I'll take it to the list. It was mainly about trying to whether there'd be any benefit in defining like target servers for TCP or UDP to help test this. But I'll take it to the list.
It's a good idea. Yeah, thank you. All right. With that, we'll move on to the first presentation, Connect UDP. David, you are up.
All right, I see slides. Can you hear me? Great success. Okay, so hi everyone. My name is David Skenazy. I work at Google and I am still a Masque enthusiast. Next slide, please. So yeah, I just saw this on Twitter yesterday and I thought it's just oddly relevant as I was making my Masque slides. So I figured I would just point it here because I thought it was funny. So Swift on Security is a well-known InfoSec account, and oh, weird, the slide just went black for a second, but we're back. And like there are enterprises where the only port they allow you to talk to is 443, and I was kind of happy that we might be able to have a solution for that. Anyway, next slide, please. All right, so I'm going to very quickly go over what Connect UDP is for folks who haven't been there at 108, which was our last session. But very quickly, Connect UDP is like Connect, but for UDP. That's all there is to it. It's very simple. And the kind of key property is when we use HTTP3, it uses quick datagram frames to avoid retransmitting your UDP packets, which improves performance. The big change since last IETF was that the working group adopted the draft. Next slide, please. So the way it works, when it's in HTTP3, we rely on the datagrams with HTTP3 draft. And so the way those work is every datagram has in its payload starts with a flow identifier. And then both endpoints kind of agree on what these identifiers mean using a header that is sent alongside the Connect UDP request. So as a client, when you say, I want to connect UDP to server.example.com, you say, by the way, the flow ID I want to use for this is 42. And if the server agrees, it echoes that in the response, and boom, you're good to go. You can start sending on that with that flow ID. You can actually start sending at the same time as sending your Connect UDP request in a stream frame, just that if it gets lost, then your UDP packets gets lost. So that's just performance optimization with some caveats. Next slide, please. What? Okay, this is what I get for letting the chairs write access to the slides. Thank you very much. Next slide, please. Okay, it's really late here in San Francisco. I'm scared to say it a third time. Next slide, please. All right, we're back. Okay, so we do have a sort of a process problem with Connect UDP, which is that we have kind of a layering of normative dependencies between drafts where, as we were saying earlier, the Connect UDP draft has been adopted by the Masque working group. And at the bottom, the quick datagram draft is adopted, which regulates how you use and the datagram frame in quick is adopted by the quick working group. The problem is you need something to define how you use datagram frames with HTTP3. And that is currently an individual draft of mine, and that's not good, right? We need, we're not going to be able to publish Connect UDP this way. Let's talk about how we can resolve this. Next slide, please. What's in these slides? Wow, slides. Drafts, what's in these drafts? So on the Connect UDP draft currently has the Connect UDP method, which makes sense. But one point that is a little weird that we might want to fix is that the datagram flow ID HTTP header is also currently in the Connect UDP draft. And then underneath the H3 datagram draft has the concept of a flow ID in datagrams, and it also has an HTTP setting to negotiate that use, but that's a little bit less interesting. And then the quick datagram draft has datagram frames and the quick transfer parameter that allows you to negotiate them. Next slide, please. So we'll let just a quick bit of background on these flow identifiers. So conceptually, datagrams at the quick layer don't have any kind of multiplexing information. And if you want to use them with a application protocol such as HTTP3, and let's say you have HTTP3 allows you to have two connect requests on the same connection. And so if you have two connect UDP requests on the same connection, you're going to want a way to distinguish between the datagrams from one and the datagrams from the other. And the dirt simplest way to do that is you put an identifier at the start, and we went with a varint like the rest of Quick because they're nice. And so because this is an extension to HTTP3, we use a setting because theoretically there could be another extension that defines this. But these identifiers have to, have a namespace so that you can refer to them and create new ones that are that haven't been used before, that unique. And on top of that, you need a way to synchronize that information between the two peers. So let's say if you decide, okay, I'm going to use datagram 42 for this connect UDP stream and 44 for that one, you need a way for the server to understand that. So how should we do this? Next slide, please. Thank you. So I initially had a way, but I had a conversation with Viktor Vasilyev, and he had a different way. So he proposed just using the HTTP request stream ID as the flow identifier. And so in a way that is pretty simple. But the main downside is it really, by its nature, forces a one-to-one mapping from an HTTP request to a flow identifier. And one of the downsides there is because of the way Quick stream IDs work, the stream ID encodes the direction of the stream and whether it's uni or bidirectional. So because HTTP requests are only client generated or client initiated, bidirectional streams, that only gives you a quarter of the stream IDs. So you would end up having way less. And so because it's a varint, you'd very quickly bump into bigger encodings, which gives you less room for application payload. Not the end of the world, but not ideal. So what is currently in the draft, and what I personally prefer, is to have a separate namespace, which is to you generate a new ID anytime you need one, and then you negotiate it with a header. So it's a separate namespace from the stream ID namespace. And what that allows you to do is have a many-to-one mapping, for example, where let's say you could have multiple connect UDP streams that share the same datagram flow ID. That feature isn't used by connect UDP itself, but it's used by the Quick proxy extension, and Tommy is going to describe that in our later presentation. And it allows also reusing flow IDs. Let's say if you have low numbers and that connect UDP request has been closed and shut down, that flow ID is no longer used. And if you received a new packet based on the Quick packet number, you can actually tell if it's the new or something old. So you could, in theory, reuse them. I don't know if we want that kind of complexity, but it's a nice benefit. And so my general gut feeling is that having a separate namespace with negotiation is more extensible and might be better. So I'd like to pause here to ask for opinions from the room about, so if we should I'm inclined to keep what's in the draft today, which is what's on the right, but I just wanted to have the conversation in the working group. So Lucas.
Hey, David. I think I raised an issue about this on one of the drafts, but because I was speaking to somebody about datagrams, and my example was, you send a connect UDP with flow ID, stream ID 0 and then flow ID 0. And every example, the stream and flow IDs are always in lockstep. And I think if you look at that, it's kind of this is a bit weird. And I think it comes to the presentation, like you have on this slide. You start with a simpler case, so people naturally want to gravitate to that. If instead you showed the datagram flow ID on the left-hand side with the requirements and the capabilities it has, and then said you could throw all that away to have something simpler, but you'll lose all of these things. it might come up with a different answer. And I think this is just a facet of where we are in Masque, is that we haven't talked about like the quick aware proxying. And I think as soon as you understand that, you go, oh, that's why this is actually really useful to have a datagram flow ID. So I like, having walked that path, I think I'm in the camp of keeping the separate flow IDs now.
Thanks. Yeah, no, that's a good point. Maybe let's go through the queue, see how people feel. I mean, the chairs can correct me, but like we're not going to make any like definitive decision here. Like we'll take anything to the list anyway. So if folks change their mind based on later presentations, that's okay. Tommy?
So just speaking for why I think we should keep with the current design for Flow ID, kind of regardless of the other extensions we're talking about, having done the implementation for this, I did find it a bit simpler to handle the logic for essentially like if you were doing a Connect UDP layer, that layer will be kind of explicitly needing to open up some datagram flow connectivity with Quick. And having that be, the Quick API can essentially offer just like, I want to open up a new datagram flow and here's my identifier. And it's much easier to kind of assign that and assign identifier from that Masque layer, rather than having to have quite as much entanglement with what you've already been assigned potentially, or what you will be assigned in the future for, so essentially there's too many entanglements with implementations about how the stream ID is going to actually get assigned when you send. And it's a lot easier to deterministically have consistent behavior if the H3 Masque layer is controlling all of it. So I think we should just stick with what we have.
Cool, thanks. And and actually a point I'll add on this that I'm somewhat getting from what's going through the Jabber, which I'm not fully following, sorry, right now, is that if, let's say, someone were to build a different application over HTTP3 or an extension to HTTP3 that, say, did some stuff over unidirectional stream in HTTP3, they could still have a way to build this. I don't know. It's just a comment to general extensibility. Maria.
Yeah, I generally often think that probably having a distinct namespace is much more flexible. I just wanted to note that depending on how you assign the flow IDs, you might need some kind of conflict handling or whatever, which makes it slightly more complicated. But that's also something that really we can't discuss right now, because I think this needs to be further specified before we can go into like a depth analysis there.
Cool, thank you. Ecker?
I mean, so I mean, first, I think like this, this longer burn encoding things like seems like a red herring to me. As Mike Bishop points out, there's like it's pretty easy to save that space. And also, as far as I can tell, it just means that you get to like 2 bytes faster than you get to 1 byte. And like at the point where you're running like a zillion concurrent. Like,
yeah, that was just.
I mean, so yeah, I mean, I guess my take on this is this is an example of you're not going to need it. And we don't need it for this application. And if we ever need it, it's easy to add. One thing that's worth, or I guess.
Wait, I'm sorry, can you clarify that?
Sure.
What do we not need and what could we add?
We do not need multiple, we do not need reusing flow IDs. We do not need many-to-one mappings at this point. And so Victor's proposal seems quite a bit simpler. It also has the advantage that it also has the advantage that you can't say incoherent things. So in this proposal, so in your proposal, for instance, I can do 2 requests with the same flow ID, and then the whole, and then I have to checking the thing falls over. And Victor's because
no, well, that's I mean, and in some cases that's a benefit. That's not a negative. Like I mean, maybe we should wait for Johnny because he relies on it. But yeah. Sorry, go ahead.
Yes. I understand that it's useful proposal, but since I'm going to complain about the proposal when I see it, that doesn't persuade me very much. But as I say, an advantage of Victor's proposal is that you can't accidentally reuse flow IDs, and therefore does not require server-facing logic to check for it. because you already have a surface knowledge, you already have the check for HTTP reuse, and simply goes one-to-one. So that seems like a significant complexity reduction.
So having implemented this, like that did not introduce any complexity in my implementation, but I recognize that
Do you check
vary.
for reuse?
Yeah, so on the server, you need to keep a map of flow IDs to a bunch of state, including like the socket that you have to the target. Sorry, on the proxy. And so like when you create a connect UDP, I just check that list and see like, okay, is there something already there? It's like literally one hash table lookup and you're done. Like if it's already like, because I'm going to add it in and the hash table is keyed off the flow ID because that's what I'm going to need when they come in.
Sure. I mean, I guess Amdahl's law. We have to ask how big this protocol is in general. But it's like a new piece. It's a new thing you have to do, and it's a new thing you can get wrong. So it's like it's not free.
Fair enough.
And going to fair amount of effort and quick and other places and quick to avoid being able to say things that are stupid. So I'm done.
So the way I personally think about this is that it's analogous to push IDs in HTTP 3. They have their own namespace that is distinct from streams, and that works. So anyway, but thank you, Ecker. Victor?
I wanted to say that the reason where I'm suggesting stream ID specifically is that streams are pretty much the only thing in Quig that exists permanently on top of connection. So if you have an HTTP connection, all of your datagram flows will be naturally associated with some stream, because otherwise, what else would they be associated with? Because nothing else really exists. And the reason I'm advocating for this is just I believe that one-to-one is mostly enough for everything, and I've read Connect Quick Draft, and I'm still not convinced why this cannot be engineered with one-to-one.
Okay, Tommy?
So to be clear, what we're talking about here, as far as how datagram flows are assigned.
You're completely inaudible, Tommy. Maybe type it in the Jabber.
Let me reconnect audio.
Cool, thanks. I'll take Lucas in the meantime, and hopefully by then you'll be back. Lucas?
And then we'll cut the queue after that, I think.
So the connect UDP method currently in draft 000 is most up to date, is defined to be used across all HTTP versions. And so there's some text in there that describes the proxy training case where if you're talking to a H3 proxy on the
so
first
I
hop,
have slides later about that specific question, Lucas, because it's a little tricky, and I have diagrams that might help. Maybe that point we should wait, or what do you think?
The point was in that we use the datagram flow ID to confirm to the Masque client on whether it can use datagram or not. So if you remove that header, we don't have that mechanism anymore. You could create another one, but you lose some other capability that we have.
That's true. If we did that, we would need to keep this header, or keep some header. That's a good point. Tommy, are you back?
Is this at all better or no?
Yes, now it's clear.
Great. Okay, I just had to reconnect audio. So I guess my question is, how much of the question of allocation is to do with your Connect UDP draft versus how we're doing datagram flow IDs in general? Because my impression was that datagram flow IDs have potentially broader use cases that are not just tied to one request on one stream. Is that correct? Are you also saying that this proposal would change all datagram flow IDs in H3?
So this, and actually that's going to be the topic of my next slide. This is actually a question for datagrams in H3 overall that is not specific to Connect UDP. And the reason that Victor particularly cares is from the web transport perspective. Web transport is interested in having a variant over there is a draft by Victor that is an individual draft currently in WebTransport that does WebTransport over HTTP3 that needs datagrams, and he went with the different option. And the important, actually, yeah, I should have said this, is we need to agree on something for HTTP3 at large, because if ConnectUDP does one thing and HTTP3 WebTransport does another thing, it's not going to work. You're not going to be able to multiplex both on the same connection. And from an HTTP semantics perspective, you should be able to. So yes, absolutely, this is completely not specific to ConnectUDP. It's specific to H3 datagram, which we need to resolve.
Right, and for that, I would strongly prefer to have it be something that is negotiated, that the flow IDs are explicitly done at a higher level, like in header negotiation here, because if we do not do that, we're essentially eliminating any possibility of a request in the future that needs to open up 2 datagram flows for, like, I agree that maybe we don't have those use cases, but that's different from saying we're expanding the scope of ConnectUDP, because like this is just like a lower level mechanism that we expect to reuse. And I don't want to have to come up with a completely separate H3 mechanism for transmitting flow IDs because we realize that we limited it too much now.
I agree, totally. So actually, that's a good segue. Next slide, please. So so this kind of covers what we were just saying, where clearly the ConnectUDP method should stay in the ConnectUDP draft. And if you look at like our layering here, like with the WebTrans working group might end up standardizing HTTP3's transport over some kind of H3 datagram. And so the question here for the group is, we have like some things that we can do, like for example, and I had this conversation with the Masque, Quick, and HTTP chairs of what do we want to do with the concept of an HTTP3 datagram? Clearly, there's a need for such a concept, and there are multiple uses. So from my perspective, defining this in ConnectUDP wouldn't be great, because then you would have things like WebTransport relying on ConnectUDP, or like depending normatively on ConnectUDP without using it, which sounds odd to me. And another option would have been to fold it into the Quick datagram draft over in Quick, but the vibe I got at the time was that very much like that draft wanted to stay at the transport layer and just do datagram frames and not merge. So I'm thinking of having 3 separate drafts and move the mechanism that allows you to negotiate flow IDs from ConnectUDP to H3 datagram. Martin, our AD, is in the queue. What's up, Martin?
I'm starting to wonder. As you know, I've been a little concerned about ECN. Whether or not it's actually in the ConnectUDP draft, I would be sad if the outcome of this process was the only way to use ECN for quick over Masque was to go to IP proxying. But if we do it, so again, whether there's another draft for this or not, that implies some sort of packet level feedback, per packet feedback, which implies a change to the datagram frame. So I'm wondering if we need. I'm not sure if there's a path besides like maybe disassociating the concept of an H3 datagram into the separate application needs that are sitting on top of it.
So and not going to go too deep down the rabbit hole into problem solving here, but so I agree that like there should be a way to do ECN probably as an extension to ConnectUDP, but I think that's totally something that we should design QDP to support. And like kind of riffing off to Tommy's earlier comment, you could imagine saying you do your ConnectUDP request and you say, here's the datagram flow ID for most of my UDP packets, and here's a separate one for congestion experienced. So you would need to have 2 flow IDs associated with one request. So that for me is kind of an indication to like that the model that we have on this slide works. So yeah, no, but I agree with you. We'll have to figure that one out, and that's kind of why I'm really would prefer to err on the side of extensibility.
Okay, yeah, so that is actually, yeah, probably quite a bit cleaner than having another field in the datagram. So I guess from that perspective, I would agree with your assessment on which way we should go, just simply for that reason.
Cool. Before I move on, do folks have thoughts on the split of drafts or which working groups they should be in? The vibe I got from the chairs was that this makes sense, and it sounds like the AD agrees as well. But if anyone objects to that idea, please tell us why.
This was a conversation amongst the HTTP Biz, Quick, and Masque chairs, and the consensus was sort of to move it in the direction of Masque.
All right, so the we'll have to have more, like, clearly from the conversation earlier, the streams versus separate namespace is going to be an interesting conversation that we haven't completely resolved, but I'm getting some sense of consensus that the mechanism for this, and if we use streams, that makes it even easier, but should be defined in one draft. So I'll move things based on the results of that conversation and then bring the H3 datagram draft to the Masque working group for adoption. Cool. Next slide, please. And now for something completely different. Let's look at some of the open issues that we have on GitHub and try to knock through as many as we can. Next slide, please.
Just a quick time check, David. We have probably like 8 minutes or so to get through these. So if you want to prior,
thanks.
Yeah.
All right. So the first one is, and that's, I have to apologize on this one. I had these slides at the previous IETF, and then I completely skipped them because it was 4 a.m. and my coffee hadn't kicked in yet. So let's go through them again. So conceptually, when you're doing Masque from a client, you're talking through a proxy to talk to an end server. And from your perspective, the proxy is one box. Let's say it's called Proxy Corp. But in practice, the way a lot of bigger corporations operate, it's not a single box. There's often intermediaries and backends. And if, let's say, you have HTTP, and the HTTP connections along these multiple hops can have different HTTP versions. So it's totally possible that you're using HTTP 3 from a client to the intermediary, and then HTTP 1.1 from that intermediary to the backend. And your connect UDP request is going to span multiple HTTP versions. And on the first hop, it can do datagram. And from the client's perspective, you think you can do datagram, but then it's not going to be able to do it on the rest. So next slide, please. Thank you. So the problem there is, if you're sending datagrams and they can't go any further, things are going to break. Right now, what we do in the draft is to use the datagram flow ID header to the server echoes the one from the client, and that's the way the server says, hey, let's do datagrams. In this case, if we were to make datagram flow ID a hop-by-hop header, that would kind of force the intermediary to drop it, even if it doesn't speak connect UDP, and ensure that we fall back to sending everything over TCP. But it's hop-by-hop headers are really no longer in fashion, so I'm not sure what the best recommended way, and I'm seeing Mike, who definitely knows UDP way better than I do, but first, Ecker's in the queue. Ecker, what's up?
I'm having a little trouble understanding how you get into this hole. So these are both operated by the same person. And so why isn't this a case of don't do this then?
I mean, that's a reasonable outcome, and I'm totally okay with that. I just wanted to ask if, like, that was an okay outcome for everyone here.
Okay. I mean, my put is, like, don't, like, if you have this kind of, if you have a split architecture like this, then don't accept, like, I mean, the client's not aware of this. So you have complete control of your writing. So like don't accept this proposal and then forward it to someone who doesn't take it. and that makes the entire problem go away.
Okay, yeah, that's a fine outcome to me. It simplifies things, and I don't personally have a use case for this, but I wanted to make sure to give people who do the opportunity to speak up.
This will also make the thing you want to do easier. So
No, exactly. So but I just wanted to make sure because intermediaries are a thing in HTTP, and I don't want to accidentally forget about them and build something that doesn't work for some deployments. Mike.
So first off, I just wanted to point out that the connection header and hop-by-hop headers aren't a thing in H2 or H3. So this is kind of
not an option at all. Whoops, sorry.
They don't exist. But the other piece here is that Connect and Connect UDP, I presume, are essentially a make this happen, I don't care how. So
yeah, pretty much.
You're going to negotiate your flow ID. Now, the question of whether that header passes along, maybe that is an argument for not using a header to communicate the flow ID for your connection. Or maybe you have to put as part of the definition that you strip it and it's just part of how you're passing it on this hop. And we'd essentially be recreating a hop by hop header then. But ultimately, like what you have on the diagram here, it doesn't matter because you're doing an H3 connection with Connect UDP. You're asking it for UDP connection, and it's going to ask the next hop for a UDP connection as well, using its own proxy. You don't have to know there are multiple intermediaries.
No, so the client definitely doesn't have to know. It's more of like, should we provide guidance for proxy operators for how to do this? And I think what you're saying is maybe in the spec we just say, hey, if you have a split architecture, be careful, and then we leave it at that and let them figure it out. That's definitely the easiest from my perspective.
Yeah, that feels like it's the right path.
Cool, thanks. No, that makes sense. Martin?
So there's been a discussion in the chat. I think the scenario that you've shown here is probably not the most interesting one to be talking about. The really interesting one to be talking about is the client talks H2 to the intermediary, but the intermediary talks H3 to the backend. And what happens in that case if the intermediary doesn't know about Connect UDP is it goes, oh, there's a new method here, and it passes it on up, and it passes along your new header field to the backend that understands all of these things.
Hold on. If the client is talking H2 to the intermediary, it's not going to send that header because it's not going to do datagrams over H2.
Okay.
So that case just works.
Okay. Add another intermediary where you have one that does H3, then one that does H2, and then one that does H3, right?
Okay.
So
okay.
And both of the middle ones don't understand this new connect method. So they just think it's just a new method that they've never heard of
so
before.
they forward the
pass
headers
it
in
straight
both
on
directions.
through.
Yeah. Oh, yeah, that's worse.
Right? And the headers go all the way back through, and it all breaks because the client thinks it's getting datagrams. The ultimate proxy thinks it's getting datagrams, but nothing is getting through this link that's H2. So what you really want here is something like Connect. And Mark mentioned this in the chat. I think it's the right solution here, which is use a setting, confirm that the other side supports Connect UDP using the setting, and you will never go any further than one hop with your request. And at that point, you're fine. And the other thing that I would suggest then is that if you happen to be sending this over HTTP 1.1, then you can put the datagram flow ID in a connection header, so it won't travel any further than you might expect.
Yeah.
And then I think you have a relatively complete solution to this, but you don't get the ability to skip intermediaries. You have to confirm that everyone along the way is willing to participate. And I think that's a feature, not a bug.
No, yeah, totally. That makes sense. Cool. Thanks. That's really helpful. Tommy? And then maybe after Tommy, we stop and we move on to the next topic. Next issue, I mean.
So yeah, definitely.
Quickly, Tommy, Can I interrupt quickly?
Yeah.
Yeah, so just the chatter in the discussion in the chat suggests that people want to go over to get through all these issues. So feel free to burn through them as needed, David.
All right, I'll accelerate like crazy. Go ahead, Tommy.
Just bouncing off of what Martin was saying, because I think that's definitely the right approach. You already do have a setting for supporting H3 datagrams, right?
Yes.
So I think it'd be useful to analyze the situation, like if that first H3 hop in the example that Martin gave doesn't know about Connect UDP, it likely also doesn't recognize that setting. And I'm wondering if we can just say, if you recognize that setting, you have to know what Connect UDP and these headers mean.
So if we were to do that, we would have to put the two in the same draft because you can't, well, I mean, it would be silly to have a normative upref. So I would be inclined to add a second setting to like have a clean separation so that if someone defines another method, say, you know, we're talking about Connect IP or Connect Network, whatever it'll be, that could, you know, have its own setting as well. Cool. Ecker?
Because I think I had maybe it's late, or earlier something, but I had a little trouble tracking the scenario Martin was describing. So as I understand the scenario, is that you have you know, a chain of H3, H2, H3, and that you send Connect UDP to H3, and it's like, and it doesn't barf all over, and this is able to do it, doesn't barf all over you, and then it gets forwarded to H2, and the H2 thing is sad. Like, I don't quite understand how we get in the hole.
So maybe let's take this offline. So I mentioned that like maybe we should move on to the next one. I think MT has a clean solution as long as you have a setting. Then like you force the fact that the first intermediary understands Connect UDP means that it won't fall over. Doesn't that resolve the problem for you?
I guess I don't understand. I'm not sure what the problem is my question. I guess.
So maybe let me try to.
Yeah, that's what I'm trying to understand.
Okay, so think of it like this. You have H3, and H2 in the middle.
Yep.
And so you start off, Connect UDP comes in. The two intermediaries don't know about it. So they forward it along over H2, including the datagram flow ID header. And then it gets to the other side. And the last intermediary, or the backend, sorry, says, yeah, this looks fine. So it replies, it echoes that, and then makes it all its way. So the first intermediary and the backend both think that everything is okay. The problem is they have an H2 only thing in the middle. And so everything's connected, but then when they send to the H2, you're saying they just,
I don't know what I'm saying. So,
No, yeah, the H3 ones, they would receive datagrams and then not know what to do with them because they don't actually speak Connect UDP. They let the request through, they let the response through, but they actually don't know what this means. So they don't know that there is a mapping between this request response and datagrams. So they drop the datagrams on the floor. That's the problem.
Okay, so if I understand correctly, let's see, I restate it. You're saying that for some reason the proxies 1 and 2 don't. They're like, hey, I don't understand. They're unaware of Connect UDP, and they're just handling as a generic request that they forward to proxy 3.
Yes.
Okay, so I guess my response to that is the same as my response to the initial thing, which is do not construct your system this way. And if you do construct your system this way, the way to handle this is the back end. If your system is constructed in a way where you do not have consistency all the way through the chain, the back end should choke when it gets the message, and that allows for incremental deployment or not. So I guess I just like all these scenarios where like within this blue box, there's a bunch of weird inconsistencies, like just seem to me like don't do those things.
Yeah, so and I totally agree. So then we kind of have two solutions there. One is we just say, hey, don't do this in the blue box. And the other is MT's proposal of having a setting to say that you support a method, which is kind of weird given how all other HTTP methods work. And that would kind of force the breakage if someone, it would prevent the foot gun. I'll have to think about it some more, because for the kind of hidden server part of Masque, the setting is kind of a dead giveaway. And I think in H3 we dropped the feature to allow you to update the settings mid-connection, unlike H2. So yeah, I'll have to think about this some more. But I think I think we're ready to move on to the next topic.
Okay.
Yeah, but thank you.
Sure,
This was good
certainly
to
we can
talk
discuss this. Yeah, I mean, certainly we can discuss this when. I mean, I guess at the point where we have a proposal to actually do something here, we should discuss that more. Whether we need something, right? I mean, it sounds like Martin floated something, but that we are changed the draft. So if someone wants to make the chance to draft, we'll have to discuss it then, right?
Yeah, absolutely. So like this would probably turn into a discussion on the list, or the GitHub issue, or PR and all that. Cool. Next slide, please. And there's some really good conversation on this in the Jabber, but it's going back so fast that I can't follow it while presenting slides. So I'll go back after this and reread through everything. Yeah, please make sure that the entire Jabber log is in the minutes, chairs. That would be amazing. All right, so now for a much simpler issue. Currently the draft doesn't have a target URI. So in the HTTP semantics documents, it very clearly states that all methods, including new methods, must have a target URI, and that includes, scheme, authority, and path. And that document has an exception for connect. And so what I did in the draft originally was to kind of mirror connect for connect UDP, but that is technically incorrect, in violation of the HTTP semantics documents. And I found when I was implementing this that I had a whole bunch of code that was validated that the scheme was present and failing the request if it wasn't. And I'm kind of tempted to just say, okay, let's use UDP:// and move on with our lives. And the path is just a single slash and you're done. What do people think about that? Oh yeah, and the proposal of UDP:// was from Mike Bishop on the issue. MT?
So it turns out that I just did a little search, and there are already 2 users in the registry, at least according to Wikipedia, because that was the most convenient place to find these. And they're weird. Maybe you can find a string that is not UDP. It's unfortunate, but I suspect you'll have better luck that way.
Lucas is proposing MT:// in the Jabber. Maybe just connect UDP://.
That would probably be okay.
Yeah. All right. Well, we don't need to bike shed the exact scheme today, but do you think that we should have a scheme?
That part I can get on board with. That seems perfectly reasonable to me.
Cool. All right. I'll probably just go with connect-UDP then.
I'm not sure that you quite appreciate the extent of the work that's involved at this point, but good for you.
Wait, as in getting the INA registration for a new scheme? Is that hard?
You got to do it right. It's going to be if you want something on the standards track, it's going to be fun. Ted can tell you all about it, I'm sure.
Oh, Ted was in the queue, but he disappeared. Oh, well, Ted offered to. Thanks, Ted. I'll definitely reach out. Alex.
Say that I think that if we are going to be getting a scheme, since we were talking about hypothetical methods for Connect IP or Connect Network or something like that, maybe if it is in fact going to be difficult to get one properly, we should consider if we should have one for all of them or one each, because it feels like it'd be unnecessary work if they're all sort of describing a similar concept.
That's actually a good idea. We could call this scheme Connect, and we could apply it to the Connect method, and now I'm sure people are going to throw tomatoes at me. But yeah, that's actually a really good idea.
There's also mask
Oh,
// being suggested in the Jabber chat, which like I think would also be okay. Because what I'm sort of thinking about is if we're doing something like connect IP, something like the port is presumably only describing the target host, right? It's not something that we need further. So I think there's definitely opportunity to do something coherent at the mask level rather than per proposed method.
I'm seeing a lot of support for Masque // on the list, and I personally really love it. So I'm sold. I'm going to go with Masque // then. So Kazuma was asking if the method would be connect. No, the method would still be connect UDP here. All right. Anyone else? All right, next slide. By the way, chairs, if for this one, since we have a clear resolution, if you could put that in the GitHub issue, that would be cool. Thank you. Yes, so this is an interesting security issue. So in Connect, when you ask your proxy to connect to a server, it sends a TCP SYN and waits for the SYN-ACK. It doesn't let you send any application data to the server, to the target server, until that server has responded with a SYN-ACK. That prevents some levels of amplification vectors or just kind of denial of service attacks. UDP doesn't have this at all. So should we fix this? To what extent do we care? Because like at the end of the day, the server sending you a SYN-ACK isn't really consent to receiving a giant mountain of application data. Like if I go talk to any website on port 80, I will get a SYN-ACK. And so do we need to solve this? Yes, no. And also if we want to solve it, how should we solve it? One way, like the simplest way, is to kind of have a rate limit until we get a response. But I'm totally open to better suggestions. Ecker.
I'm not sure I have a better suggestion, but it seems to me that like the point Ben just made in Jabber is the salient point, which is that that SYN-ACK basically opens the connection, but the real defense is that the proxy in Connect does TCP rate control, and in this case that is not true, right? In this case, basically because the proxy doesn't get to examine any of the quick data, like it has no idea like whether things are being hacked or just thrown on the floor or whatever, right? And so like the rate control still has to happen end to end. And so given that the most likely things that are going to be killed by this are going to be in fact quick servers and therefore will accept connections, and you won't even get to observe, like, I mean, now all the things we did to make it like impossible for like middle bias to inspect the traffic are going to come in to bite us in the ass. Like basically, so like, I can open the connection to the server and just like pour traffic down it, and the proxy doesn't even get to observe like that the server sent me an RST, right? So like I mean I can see why it would be appealing to do this, but I think it doesn't actually help very much. I guess
I totally agree with you. What do you think we should do from here?
I don't know. I mean, I think like this seems like an inherent problem actually. To like basically, I mean, if we just step back from this whole thing and you say like, I mean, so the traditional thing that you would do obviously is that the server would penalize the apparent client, right? But in this case, that means penalizing all the people who are co-tenanting on the same proxy, which seems bad. And so if we have, I mean, just to clarify, right? If like if ProxyCo is operating some giant proxy farm and like a lot of people are like connected to Google, then and like one of them is being abusive, Google Google penalizes ProxyCo and they penalize all the people who are connected to Google as well. Yeah. This seems like a problem which actually we have to deal with more generally, in terms of like the manageability of the whole system. And I don't think I have a clear answer, so I'm not going to step back. But I think that's. But I don't. In any case, I don't think we're meeting a new issue because I don't think the initial window is the problem.
Yeah, no, I agree. Because if we take an even further step back, like there's the denial of service problem, but there are like other ones. Let's say, for example, that you use Connect today and you go and you deface a Wikipedia page. like if you do this in some countries in the EU, they will like come after Proxy Corp with like warrants because that IP showed up in the logs, and let's say you put something that is very specifically illegal on a Wikipedia page, they will come after you. So I think the solution might be to just say, well, don't let people you don't know use Connect or Connect UDP. But if there is a very technical solution that makes sense and is not going to get in the way, let's do it. But yeah.
Right. But it's just a matter of scale, right? Of time scale, right? Which is to say that, like, ProxyGo has like a million customers, right? And one of them is being like hyper abusive, and like Google wants to turn that. I mean, when Google's being spammed like this, I'm gonna turn that problem around like this, right? And there's no way for them to do that. Whereas, if you deface the Wikipedia page, law enforcement comes up and they're like, hey, this user defaced the Wikipedia page, that's like a slow motion event, whereas this is like an emergent event. So I think the timescales are quite different.
Yeah, fair enough. That's true. MT?
Problem here is that there are two parties that want to confirm permission to send, and the client, presumably, if in the protocol that it's talking, whatever protocol that happens to be, will be verifying that the server wants to talk to it before it sends it any significant amount of traffic, if it's a well-behaved client. But what we're looking for here is the server being able to independently verify that the server is, the proxy, I should use the word proxy, the proxy is able to verify that the server is willing to talk to this particular client as well. And that's challenging. If it were a quick connection, I could say, you just watch for the initial, original destination connection ID to come back, and everything will be golden. But that doesn't work because you have to understand the protocol in use at a level that is probably a little bit too much to ask at this level.
Yeah. Well, to the point where we would then as a quick enthusiast, I would be extremely sad if deployment of Masque caused us to ossify a quick version. That would be like the worst possible outcome.
I was about to get to that because essentially what you have to have at that point is that the proxy is decrypting the server initial in order to verify that it's been generated with the right keys. That's kind of not cool. So this is going to be a little bit challenging. I don't have an answer here.
One potential suggestion that actually came from Olivier Bonaventure earlier this week, so I didn't put it on the slides, but or actually it came yesterday after I made the slides, was about ICMP. What do you do on the proxy if you receive port unreachable from the server? And that's kind of a mixed bag of, in a way, it kind of helps us solve this problem to some extent, but it actually doesn't solve it. No, it only works on open ports, because if you talk to a quick server, it's never going to send you ICMP. So it doesn't help here. Never mind. I think I'll need to think about this more.
Well, we do have experience with turn, and so some of that experience might inform the choice that we make here. But that's not to say that the decisions that we've made in turn naturally apply to something like this either. So,
yeah,
word of caution.
Cool. Yeah, that makes sense. Jana?
I'm not sure if I have a lot more to add here, but I'm just trying to figure out how you can solve this at all. I think it's fundamentally the best I think you can do here is add some sort of high-level protection. We've done this for years for any thing that runs on top of UDP. We call it a circuit breaker, and we apply circuit breakers to pretty much anything that says I'm going to run on UDP, but I don't have like a tunnel, for example, that doesn't necessarily have a congestion controller. All you say is, well, if you start sending too much stuff too quickly or something like that, then there's a circuit breaker that goes into place. The problem you're facing here is exactly that. It's not a new problem, but I'd imagine that it's certainly different than Connect, because you said with Synac you get a very clear signal. But yeah, I don't think that you can really solve this as a protocol mechanism. I think the best you can expect is suggest some things for deployments in terms of protections, because that's ultimately what you're looking for here, is that you don't want to allow abuse or a DOS sort of a situation. So I imagine that the best you'll be able to do here is suggest some things for a deployment to employ mechanisms to employ so that it doesn't exhaust resources.
Cool. Thanks. That makes sense. Yeah, I think we might have a proof of impossibility to some extent. All right. Next slide. And next slide. And yeah, so do we have any questions that are not specific to any of these issues on Connect UDP? We are clearly over time, but thank you. Like, I think those conversations really helped. Do any comments or questions on Connect UDP before we move on to the next presentation? All right, I think I'm done then, and thanks everyone.
Thank you, David. All right, Alex.
Waiting for the slides to appear.
MeetEcho decided that it lost the ability to share the screen, but they will be there shortly. There we are. Slides.
All right, thank you. Hi, my name is Alex Chernohovsky. I've worked with Dallas and David Snazzy on these slides. Dallas, unfortunately, was unable to present today, so I am taking over for him. Next slide, please. So we're going to first start off by talking about some of the unchanged requirements from the last time we talked about Masque IP proxying. So I'm going to go a little bit fast over some of these things because they're unchanged, the exact same slides that we had last time. It's mostly a recap. Next slide, please. So there's 3 general use cases. We're going to go into detail of all 3 of them with some worked examples after some clarifications later on. So our first sort of use case is point-to-point. We want to create a tunnel between 2 endpoints. This could be used for something like, you have container networking and you want your container pod to be able to talk to another one on the same machine with different addresses, or possibly on a different machine with the same addresses. Then we have the point-to-network use case. This looks more like a traditional VPN, sort of if you were to go and buy a VPN from one of the commercial providers in order to get a different IP address, either because you want to access the network from a different geographical region or privacy or some other concern, but you're currently using something like IPsec or DTLS in order to get there. This is also frequently used by enterprise networks in order to get access to their internal things, which are not generally exposed to the public internet. And the last use case that we're sort of interested in is the network-to-network use case, which is also called a site-to-site VPN. A lot of times, enterprises or small businesses will use this in order to connect all of their different branch offices together, for example. This is also kind of interesting when you have devices that themselves cannot run VPN clients that you want to connect to a VPN. Next slide, please. So again, sort of unchanged here. We're going to first go over the security requirements. We want whatever we do here to have transport security. So we think that this should only run over something like Quick or TLS because that provides mutual authentication, confidentiality, integrity. Sort of the next thing that we also want is that this traffic should be indistinguishable from regular HTTPS web traffic. This only really applies to network visible unencrypted bytes. We're not considering traffic analysis in scope for this requirement. Authentication, we want to have some mechanism for a client to authenticate to the server to establish its sessions. We don't want to specify yet what that should be, but it could be something like an OAuth token or some vendor-specific implementation. And lastly, identity. The endpoints that are involved here need to be able to have some sort of cryptographically authenticated identifier to determine the identity of their peer. This sort of ties back into the earlier authentication requirement and can basically be like, oh, cool, I have proof that you authenticated to me. And if it's something like a stateful protocol, again, like OAuth, then you sort of get this for free. And to Ben's point in the Jabber, yes, it is an authorization protocol. We are sort of assuming that once you are authorized, you can be later authenticated by policy or whatever other mechanism that you want to do. Next slide, please.
Ecker's in the queue.
Oh, sorry.
Go ahead.
Go
Can you
ahead.
go back? Yeah, so I think go back. So I think we're sort of bite shedding, but it may be relevant. So it seems to me that there are three. It seems to me that there's sort of a how should I phrase this? So conventionally the way, so maybe I'll start back into it. So conventionally the way this would work would be, if this were like Connect TCP, is that over H2 is that you would have you run over TLS, so you have this first point you make, then you'd have the server cryptographically authenticated at the TLS layer and bound into the transport protocol, and the client cryptographically authenticated, if you want to call it cryptographic, at the application layer. And in fact, it's not necessarily even cryptographic, right? I mean, like, it could be using a password, right? And so I guess I think that so the point being, I'm having trouble with this, I'm having heartburn with this like last point about identity, in the sense that I think that it's clear that the server has to be cryptographically authenticated, and that has to be tied into transport, but it's not clear that the client is cryptographically authenticated in a meaningful way. There are some applications where it's true, but there's somewhere it's not.
Yeah, I think this is mostly a matter of wording, and I certainly would be interested in a suggestion here. I don't mean to imply that something like username or password would be unacceptable for the client.
Okay, I'll see if I can find some way to rephrase that, because I'm glad sounds like we're on the same page. It's not like it's just tests.
Yeah, this is something that we were struggling with, because there does not seem to be a good short form of describing exactly what you bring up, and I totally agree that if we can come up with a better way of phrasing that, I'd love to see it.
Sounds good.
All right, thank you. So moving on to sort of session requirements, we want the client to be able to establish an IP session along with configuration options it may have. Sort of one thing that we've sort of been assuming here is that it is valuable for a server to be able to accept or deny the client's request at its discretion. So for example, the client wanted to talk to some IP destination that we didn't want to permit by policy. The server is not obligated to forward traffic there. One also additional requirement is we'd like to proxy IP packets. I think this is probably self-evident in something called requirements for IP proxying. So whatever mechanism that we use for the underlying data transports, which either should be something like quick datagrams or stream frames, we should be able to take the IP packets unmodified in their entirety. And we want to support both IPv4 and IPv6, and also any future IP versions should they exist. We also believe it is important to multiplex different IP sessions over the single HTTP connection. Sort of going to some of the discussion that we had at David Skenazy's earlier point around flow IDs. I want to quickly clarify as a result of that I don't necessarily believe that we need to multiplex over different flow IDs or the same flow ID. I don't want to specify that here, but I do think that at least based on what we seem to be heading to in the Connect UDP draft, that seems like we're going to already have this capability. And lastly, one sort of important thing here on session requirements is that we want to be able to support both H2 and H3. Clearly, we do believe that there is a strong preference for using H3 where we do have the datagram frames, but we do think that H2 cases for fallback would be useful in places where UDP is unavailable. Sort of using an example from industry, I know that I believe Cisco's VPN product uses DTLS and then falls back to TCP over TLS. Sorry, TLS over TCP in the event that the network blocks UDP. And we think that is a useful thing to continue to make available. Miriam?
Yeah, actually on the proxying IP packets, you said this very obvious because that's what we want. However, the way you phrased it here, it's not completely obvious because you say in an unmodified entirely. So that rules out any kind of IP header compression or anything like that. And I think that needs more discussion.
I do not think it is appropriate for a Masque server to be performing any sort of compression. I think for the Connect IP case, we really should be moving the packets along entirely. And I think that if you want to go and introduce any sort of thing which is going to apply transformations to the IP packets, it should be phrased as an extension.
So I totally disagree. I think this is the point where we need more discussion. That's what I'm just saying.
David?
What you just said. An extension sounds like the right way to go for me.
Do we have a issue on the GitHub for
There's
this,
a
Mary? And if not, can you?
Yeah. And what, in terms of design principles, and I kind of like touched on this in Connect UDP a little bit, I think as a working group, and maybe we can have that discussion at some point, it might be worth it to try to, so my opinion here is that we should have both Connect IP and whatever IP proxying becomes be really minimum viable products, like as dirt simple as possible, but extensible, so all sorts of cool features. So trust me, I've implemented IP compression for a proxy before, and it makes huge performance wins, but it's never a requirement of the core thing. And actually having these kinds of things as extensions is much better because like I built in compression to the first thing, and it turns out that we came up with a better compression scheme, and that was a nightmare. If you built in as an extension to the first mechanism, you can replace it with another extension, which is often a better way to go.
So I guess I can reply, right? So with compression, like what I have in mind is really just not sending the IP header. I'm not talking about certain compression scheme. And if you don't send the IP header, you need some kind of additional signaling, but all this signaling is completely identical to Connect UDP because there you don't have an IP header neither. So you need the same kind of signaling mostly. And the benefit you get is just like reducing overhead. I think it's super simple because we already have Connect UDP. If we wouldn't have it, then it wouldn't be simple. But as we have it already, and we can assume the proxy has implemented already, it's simple to reuse that. And especially if you think about the kind of VPN use case, that like reduces actually complexity and makes it much more simple. I understand that like for the network to network case, it kind of makes it more complicated. But for the VPN case, it's much more simple.
I just want to say that I disagree with most of that. I think that if you go and do something like removing the entire IP header, you're basically tying yourself down to a single connection, and you basically only can handle something like point-to-point or point-to-network. And as a result, I think here in the interest of being generic, and we're actually going to go through this later in the slides of the work examples, with the requirements as we're currently stating them here, we're stating that we have the ability to do so. We're not saying that it is exclusive. Like we're saying that you have to be able to forward IP packets, like whatever implementation we do needs to have this capability. It is not saying that it exclusively only must do IP frames. We can go and introduce extensions as you propose in order to have the exact same semantics as with Connect UDP and not have to go and relay that redundant data. But I don't think that that is a thing that should be included in the base drafts.
So I think I agree with you that this is probably two different separate mechanisms, and we might need both for these different use cases because they're very different. But the reason I came here was more like a VPN use case.
I am also here similarly for a VPN use case, and I think that we have a different idea of what a VPN does. Because what I don't really understand is why you want to go and remove that redundancy, because traditionally VPNs are implemented at the IP layer. If you're going and removing those IP headers, it's not a VPN.
The reason it's really just overhead, and given we have these methods already, so it's like optimization here.
But it's an optimization that is going and adding additional work to the system. I don't understand why you want to go and do something differently here than every other prior art in VPNs.
Because if you not connect two private networks to each other, then making sure that you handle the IP addresses correctly. If you connect like to an open network, making sure you handle the IP addresses correctly gets the complexity in. And by just letting the proxy handle that, you can avoid like these kind of things. And if you have the proxy handling the IP address, there's actually not much more to do for the proxy to create an IP header. It's just
I strongly disagree, because what you're effectively going and saying is that the VPN client needs to then go and undo the work of the operating system.
So
I think that is.
that have some more discussion on this, and if we don't already have a GitHub issue, can we have one? But as we do that, can we try to make sure that we're framing the need for a requirement this way or the other with the use case that it's supporting, rather than the solution that we think it's going to enable?
Yep, that sounds good. Thank you.
Thanks.
There's 2 more people in the queue, I believe.
Yeah, Eckerd, do you have something on this, or can we make it quick?
I was going to try to make it quick. I think going back to requirements, right? I think that the key requirement question, it seems to me, is do we need to support, I guess, what you're calling site-to-site VPN? And if we do, then you clearly have to have the IP header in the thing, or it's not going to work. So I think that's. So I think my understanding was that there was some agreement that we had to be able to support site-to-site VPN. And if people don't think that, then we should debate that point. And then I think the question then becomes is there a requirement to have is requirements not desirable to have a more compact compressed mode for when you're doing these a more standard user facing VPN where where you're just trying to conceal what you're watching your location from Doctor Who, when you're watching from the BBC to watch Doctor Who, right? I guess one thing I would say, and I think I said this in an ADD meeting, this is one thing, things I don't like requirements documents. It's people that want to negotiate the entire protocol in the requirements document. So I think the question of the second question is something we can face down later. I think the core question is unless somebody thinks we should only have a mode in which the IP header is not carried and it's then reconstructed the other side, then I think we clearly need the mode that is in this document, and we can discuss whether we need a more compressed mode later.
Thank you, Eckerd.
Tommy?
Comment on this. While I definitely agree that we need to support full IP packets in here, I think we need to be careful to ensure that we do not have the requirements document limit it to saying it will only do that. I know you're expressing yes, you don't want to have the IP header compression. I think that needs to be allowable in the protocol. That not all deployments will do it, but we need to leave it extensible, and so I think the extensibility needs to be a requirement.
I absolutely agree, and I would like to point out that the slides do not say exclusively.
Yep.
It is already the case.
I understand, but I think all of this entire conversation could be solved just by adding a requirement to be and there is a way to extend it to not have to do the full thing, and then
Sure. I'm more than happy with that.
Yeah.
All right. In that case, I believe next slide. A few other things here. Reliable transmission. We do believe that in general, these things are going to be going over datagram frames and will be unreliable, although there are some cases we have seen where it may be desirable to go and ask for certain packets to be sent reliably in order to help optimize session establishment. For flow control, we would like these connections to not be subject to flow control so that we are allowing the end-to-end principle to take place for the underlying TCP session. And finally, load balancing. We have seen that some server and client implementations bind individual things to individual threads. So we think it should be useful to allow for additional streams to be created to allow multi-threaded implementations to increase throughput. Magnus?
Yes, Magnus Westlund as an individual. About this load balancing, do I understand it correct that you're really mostly focused on ensuring that you could have multiple quick connections so that you could get those, not be limited by the proxy's performance in individual cores?
That's certainly one thing that I would be interested in exploring. I've also seen some suggestions and implementations that want to process individual streams or potentially datagram flow IDs on different cores because the crypto is sufficiently separated out. So I think both of them would be worthwhile to be able to at least not preclude.
I think this context needs some more thoughts on the feasibility of realizing this, especially when it comes to, I mean, flow detection and reordering issues and things like that. But
So I don't necessarily. So when you say flow detection, are you talking about the underlying IP packets being transported, or are you talking about like the datagram flow?
Yeah, the inner IP flows.
Yeah, so
and how you
I
keep
do
those.
not want to specify in this document, because I think that there is enough other prior art and other RFCs specifying what to do with flows as to how to map individual flows onto individual datagram flow IDs or quick streams or what have you. I think that is, outside the scope of Masque. I am merely saying that I think it is important that for IP proxying, we have the ability to have multiple, possibly independent flows in the Masque sense, that those IP flows can be mapped onto.
Okay. I think that sounds. I mean, this is part of the solution space, or etc. For that, resolving that. But I think you need to have clear indicators of that there exist solutions that can make this working, and pointing to some of these. But yeah, it's fun for the solution. But I think that is going to need to be discussed, and I wonder about the complexity of solving these.
All right. I mean, I'm fine to go and add some text saying that that is out of scope, and there are other things that sort of dictate how to use those things. But like, I think in general, that's sort of one thing which makes this sort of requirements document hard, is that while there are use cases and we are talking about some of these things, we're talking about capabilities here. We're basically talking about things that we want the protocol to allow. We're not specifying things that implementations must do, and we're not necessarily even saying that we will do all these things. We're talking about guidelines for how we want to make sure we make things at least possible. And when you bring up concerns like this, like I don't want to minimize them in any way. They're very valid, but they're much more implementation oriented and have like real world concerns than I think is appropriate for a requirements document. MT?
I think that makes absolutely no sense to me. If we're sending IP datagrams, I imagine there's an expectation that you'd want them to be in datagram frames. Why would we even consider streams, and why would streams be the unit at which you can divide things between CPU cores or whatever it is? This seems nonsensical to me, even
So
face value.
I think this is, again, a terminology problem. So one of the things that we did in the draft is we used the terminology data transport to refer to either the H2 or H3 stream or the datagram flow ID tuple thing, and that a particular set of IP frames can be mapped onto. So basically, the reason we chose the word stream here is probably an editing error, because we also wanted to support doing IP proxying over H2. And
I'm still not saying how this is relevant. So I can imagine having a requirement that you be able to create multiple connections so that you can access the same network with the same IP address from multiple proxies. But that's all like that. It seems a little too much for me.
I do not think that this is about multiple connections. I am very much talking about within the individual H2 or H3 connection. We did see in our own implementation a difference when the multiple streams were in use with Google Quick. And as a result, we do believe that this is an important capability.
I'd be curious to understand what's going on there, because I don't see any way in which that would make sense, but happy to see data. I don't think this needs to be a requirement, though.
I do think having the client or server be able to originate streams to choose how they send data, even if it ends up not being for load balancing, is an important requirement. So maybe the fix here is to not put it under the guise of load balancing.
I'm absolutely convinced that if there are performance gains to be made by amending the protocol, we will seek to do that as the time comes. But this is back to Eka's comment about litigating the details of the implementation of
all right.
protocol.
In that case, I would be happy to strike this requirement, because it seems to not be terribly important, and also controversial.
That'd be wise. Thank you.
Jana?
Thanks, Alex. I wanted to echo Martin's comment, but perhaps slightly differently. You were making the case earlier, and I was 100% in agreement that we want to build something as minimal as possible in terms of IP forwarding and in terms of being an IP level VPN. And to that extent, I think this might again fit in that space of an extension. I don't think that you want to forego any performance benefits that you get for doing this potentially, although it does seem weird. I'll agree with that. I'm also curious to understand where this exactly yields performance benefits. But that said, if it's an extension, if it's something that you can implement if you care to, then it's valuable to have as a side thing. But I wouldn't make it part of the core requirements.
Yeah, I'm inclined to agree.
Just wanted to chime in a little bit to the comment that you made, Alex, about it's kind of weird doing a requirements doc like this, because I think it is, and that's something that we should kind of acknowledge and meet up front. Is we built in this ordering structure to how we wanted to approach this work as a group. And what I think we're trying to accomplish with the requirements and definition of use cases is very much not let's describe the solution that we think we're going to implement in the protocol details of how we're doing it, and you've agreed with that, so that this isn't a disagreement there. But I think our main task right now is to find the minimal set of things where whatever solution we end up picking and achieving consensus on as a working group is something that if it did these things, we would be happy. And by happy, I'm defining that as, I would have something that I could use for my use case to deploy. And so I think really the conversation that we're trying to have is, what are the use cases that we believe we need to support, and what requirements do those place on our solution, not what are the requirements that describe a current solution of any form. And that's I think something that you're walking a very fine line of doing, and thank you for endeavoring to do that, because that's not an easy thing to do. So just as we're having the conversation around this, the more we can keep it grounded in the use case, I think the happier we will be. But that is always a hard thing, especially when there are a couple of different things that may already even be deployed. So.
Yeah, and I definitely recognize and appreciate that. And I think the feedback that we received here about this load balancing requirement is better omitted or included as an extension is a good and useful one, because it is the one which I think is probably least grounded in a particular use case that we will describe. Next slide, please. Things out of scope. This is just a recap. We're not going to talk about how you assign IP packets, or sorry, addresses to your IPs. We simply say that there is some mechanism, because I don't think the protocol itself needs to be concerned with it. We're not going to include any sort of network address translation or modification of packets that they're forwarded in scope here. In this particular thing, I think there's enough prior art on how to do that. We're also not going to talk about how you actually get IP packets off of the physical network. That's an implementation detail. Miria?
Yeah, I think we cannot avoid to totally talk about address translation. There is a use case where where the client wants a proxy to hide its IP address from the server. And in that case, doing the address translation is not that complicated, but you need to talk about how IP addresses are selected.
I would like to clarify. What we are saying is out of scope is the mechanism by which IP addresses are selected. What we're saying is some other component will tell the system this is the IP to use. We are not going to go and talk about policy that is out of scope for the protocol. That is all I'm saying. So I agree that the use case that you want to solve is important. I am saying that I don't think it requires any Masque protocol changes.
So I think usually it would be the proxy that has a certain range of IP addresses that it can use, and giving guidance how to use these IP addresses is also something important. I think it's just too tightly phrased in the draft.
If you would like to suggest a wording change, I would like to see it. But my goal is to allow you to implement exactly that thing without requiring any specific mechanism in the protocol.
Yeah, I mean, like I think you need some signaling to actually give, for example, the client some information about what the outfacing IP address is, or at least that there is a different one, that this is applied and so on. So I think maybe we also want to add a requirement somewhere that this is supported.
Why don't we revisit this after we work through some of the examples later on in this presentation? Because I think there's actually enough capability in what we are envisioning to actually achieve that. David?
Quick point, because I think I'm detecting a misunderstanding between folks here. So think of this. So the way, like we've been thinking as the authors of the document here is, all right, how do we just proxy IP packets? So conceptually, like, how do we do the ESP part of IPsec? Just what is the wire format that you take these packets and you shove them there, and maybe a little bit of the IKE part, which is, okay, how do you get addresses and routes communicated through the control channel? So NAT is something for like the VPN use case you will absolutely need. But if you look at all the IPsec documents, none of them mention NAT. Part of that is that people pretended NAT didn't exist at the time, but conceptually that doesn't need to be in those documents. You just need a way to say, okay, these are the IPs that we have, these are where we're gonna send. What we're saying is out of scope is how you pick your one IP, like, or if you're going to do a NAT, what kind of NAT are you going to use? Those are things that are kind of going to be on the same box as your Masque server, but they don't need to be in this specific document. They're a separate thing. That's kind of what I was trying to clarify.
Can I quickly reply? So as I said, I think this is too generally phrased, so more words might help here. But I think there's also the case where actually kind of the client wants to influence like how certain IP addresses are picked. For example, if the client wants to have a stable IP address or something. So this is really too broadly phrased here, I think.
Let's go through some of the worked examples, and I think it might clarify. Actually, before we do that, Ecker just entered the queue.
I think I understand what you want, and I'm having trouble with the text. So let's just see the examples, and we'll see where it works out.
All right. Next slide, please. So one of the things that we've got feedback on from, previous slide. One of the things that we got feedback on that we sort of realized was a terminology issue from last time when we were talking about IP assignments and what previously was called a IP route. We have recognized that those words have implications that we did not want to convey. So we have opportunistically chosen to instead call these reachable destinations. So a reachable destination here is the client or the server going and saying, hey, I can make these following IP addresses reachable to you over this capability. So why don't we go through the next slide example real quick, which I think will be of interest to Miria because it is sort of the point to network sort of classic VPN example. So here, the client says, hey, can I have an address range, please? And the server will say, sure, you can have 2001 db8:b/64. So that is the address that the client would use in this model for any outgoing packets which will transit the Masque server. So if the client were to go and use any other address, the server can and probably should go and drop it because that's not an address that it offered to forward packets on behalf. And also what the client also needs to know is what's reachable using that address. So the server also says you can reach anything in 2001 db8/32. So not only if the client uses a source address, which is not one which it received, but also if it tries to send to a destination address, the server is not obligated to forward the packets along. Ecker?
Queue fail.
Okay, Marianne?
Yeah, so I see why you want to provide reachable addresses in the network-to-network case, but I'm not sure why you need it in the point-to-network case, where the network is the open internet.
In the point-to-network case, think of a office VPN, where you want to provide a reachable destination, which is the internal addresses of the office, but you don't want to proxy the client's entire internet.
Yeah. Okay, but so like in my case, it would be reaching the open internet over
Yes.
the proxy, right? So the network
Yeah,
is
so
the
you
open
could-
internet.
So you could do like a 0/0 as your like, I will let you reach anything response. So it could be anything as broad as the entire internet, but it could be something as specific as only this range or these set of ranges.
Yeah, I'm not sure. I understand your use case. I'm not sure about the requirement, but this is because this is also information you could get like, and sometimes out of band or hard configure or whatever. So not sure.
Well, we think it is valuable for the protocol to be able to pass it, right? Because if the client might be something stateless, or the server might have a different network configuration depending on like if it got geographically load balanced differently. So like, while I agree that it could be done out of band, I think there is value in letting the server additionally provide that information so that you can have simpler clients, or you could have, as you mentioned, thicker clients which have that information out of band. But again, this is a capability, right? This is something that we think the protocol should allow. We're not necessarily saying everyone has to use it this way.
It seems more like to me that like if you have some kind of general signaling mechanism that can like provide some kind of information, that's enough as a requirement.
Yes, I think we do, and I think what I'm explicitly saying is I think that IP addressing information generally should be going over that signaling.
Yeah, but so the requirement is having the signaling, and this is just like one use case for the signaling.
Can we take that to an issue, please, and keep moving forwards? We are running low on time, and we've got a whole lot more to go through.
We only have 2 more slides. Next slide, please. So the thing that we wanted to say next here is that point-to-point is sort of a degenerate case of point-to-network, where rather than trying to access a large range, we're just trying to access an individual range. So it looks very much the same. You ask for an IP, and you just have a reachable of a /128 rather than a large subnet. Next slide. And finally, network-to-network is sort of a degenerate case in the inverse direction, where rather than saying, here, you have an address, we can say, client says, here, I'll let you reach one range, and the server says, I'll let you go and reach another. Next slide. Oh, sorry, Magnus.
Thank you. Yes, so I guess this is, I think this is much clearer than what was before about really reachable, etc. So to avoid those SAVI, I mean, source address validation requirements and even routing would be saying that as long as the Masque server is a good citizen and only offers what's in that local routable, it knows routable domain, you could avoid those aspects of having to deal with either route injection in your upper box there along the blue line, or for that matter about actually verifying the addresses and the ownership of the addresses.
I recognize what you are saying, but this is, I think, out of scope. This is merely talking about the protocol being able to support this thing. Someone may wish to go and implement reachability as you described by going and doing a route injection and needing to go and do such validation, or they could go and be ranges that the endpoint, that the like same entity owns and already has like some sort of ACLs involved here. These are concerns which I think are better handled by standards and systems that already exist. This is talking about a signaling mechanism.
Yeah, so the requirement is a signal mechanism, and then the security implications of this mechanism in the general case is a further need. That's, I think, is the problem I see, is that you actually, for a secure deployment using this mechanism, you either tighten the scope to a particular use case or a particular usage, or you have to implement additional mechanisms.
I don't think that follows, because the server is not obligated to go and forward any packets for a reachable destination. As per the point we mentioned in the requirement, this is merely an advertisement of what can be reached. It is not an obligation. So if you go in, first of all, you don't have to implement this capability. And second of all, if you do implement this capability and the client asks for something which is a violation of your policies, then you are not obligated to forward the packet. I don't think these concerns exist beyond what already exists if you were to do, say, a IPGRE tunnel.
Yeah, but I mean, that tunnel also need to at least has those considerations. So I think it comes down to pointers later on in the security considerations and things like that with the actual deployments. And because you're integrating several mechanisms into one here. I think that's going to apply later on when we come to the solutions.
I really think that we're having a communication issue here, because we are not mandating that anyone implement this. This is talking about the protocol being able to describe something. It may translate into the implementation as you describe, but no one is obligated to implement those capabilities. There's still additional authentication authorization requirements here. And there is also prior art. I'm not entirely sure how I can better message this.
So I'm taking this, I think I understand you. Yeah?
I think we need to cut it. We are extremely short on time now, and there's still one more person in the queue. What could I ask you to take this to an issue on the requirements draft to discuss it there?
You already have an issue, so.
So let's move it there.
All right, Ecker, and then that will be it.
Then, I'm sorry, but can you go back 2 slides to slide 10, the point to network one? So I apologize for not raising this earlier, because I think I got a little lost. I'm kind of tired. In your scenario, I'm triggering to this first bullet point. You say these addresses are internal to the tunnel, right? So like in this classic use case where I'm like in the US and I want to appear to be in the UK, right? I'm going to emit packets with. I want packets to come out the other door, at the door on the other end with the UK IP address, but locally, of course, I have a US IP address. And I'd thought when you first said this that the server was going to tell me, "Hey, when you transmit using the UK IP address," and I'll just leave it. But now that I see internal, I don't believe that anymore. So now I'm a little confused.
Yeah, sorry. I think this was an edit that was introduced later into the slides that is a little bit unclear. In this worked example, the addresses here are internal to the tunnel, in that we're not talking about the outer address of the quicker HTTP3 connection. We're not saying that this is a private space IP address. So in your example, if we were to give out to over the Masque connection a public UK IP address, that is what would be here. So your outer packet would be your US IP address talking to the Masque server, and then inside of it, you would be using the publicly reachable UK IP address.
Got it. Okay, that makes sense. Understand. Okay, so in this case, there would not need to be any NAT, because I'd be effectively internally NATing at the client.
Yeah. So there is a small gray box here of saying out of scope policy and NAT. One could go and choose to do IP address translation through NAT if they wanted to, but it is not a requirement that we think is presented on top of the Masque protocol.
Okay, great. And if the chair should feel free to come up again too far into solutioneering, but many VPNs allow you to actually attempt to select the address address range in some way. Do we think do we think that has to be supported? And if so, does it have to be specified here? It's like you say, look, I want to watch soccer, so I need to be in Spain, right? I don't think we have to like specify technology for that, but I wonder, does that have to be? That would have to be at this level if you wanted to make that assertion. So I just don't know where this fits in our life.
Yeah, I think that's interesting. I was personally sort of imagining that selection would be happening outside of this by choice of the Masque server you choose to connect to, but I could totally see an extension adding that additional information to the signaling mechanism.
Thanks.
And I turn it over to the chairs.
Valerie's in the queue. Did you want to?
I previously said Ecker is last, but that is up to your discretion.
I think we're about out of agenda time anyway, so if we want to finish with this one last comment, and then we'll talk about next steps.
Well, okay. So I want to point out that all the issues were discussed in IPsec working group long ago, and IP2 performs traffic selector negotiation in a very similar way. And I just suggest to look at our experience, and actually the client, the initiator in case in IP2, not only may ask for an internal IP address, it can only suggest its view of the policy on which IP addresses it want to go to. So it's kind of negotiation, not just server signs IP range where it is allowed to go. So I just suggest to look at our experience, at our work in IPsec working group, because it is very similar.
All right, thank you. Will do.
All right. Thank you. And with that, we have a solid 6 minutes left. Tommy, you're next. We've been chatting about the potential of scheduling an interim to try to get some of the, as is all the rage these days, to try to get some more face-to-face-ish discussion on both of these issues. And I think both of our remaining agenda items would fit very well at one of those. So Tommy, you're welcome to fill 5 minutes, or if you want to wait for that, we can have Miria fill 5 minutes.
Right. So I certainly do not want to get into any other presentations. I think an interim would be a good idea. But since I was next up, I will take advantage of a little bit of time, if you don't mind, to kind of make a broad meta comment that I think overall it would be good for us as a working group to define our stance and our plan for extensions, because it seems very clear that we have, you know, these core items of connected UDP and IP tunneling. And I very, very much agree with the notion that, you know, we should keep focused on them. We should have them be minimum viable products. But in, you know, the conversations for both connected UDP and IP tunneling so far, the idea of being able to extend or tweak these very powerful mechanisms has come up a lot. And the presentations that were to follow were going to be about that. And I think we should like at least clarify, either from the chairs and the AD, or maybe even in the charter as well, the plan for, you know, kind of publicly saying we plan to be able to support extensions. When are we going to do that work? What are we going to delay on? And make sure that it informs the work that we are doing in Connect UDP when we're deciding things about the flow ID, et cetera, to make sure that we are thinking about that and we know what our plan is. Also, I would like to just bring up for this group, if anyone wasn't at int area, there was a kind of a large confusion in which there's a whole quick proxying work that was brought up there that really, really overlapped with Masque. And I think there was a sense there, I don't know how exactly the sense came about, but a sense that, oh, Masque is really focused on some tight use cases and can't be used for this particular use of proxying, and therefore they need to go do it in int area or do it somewhere else. And looking at it, it seems extremely similar to what we are talking about right here with the IP requirements. But I think the fact that this problem has occurred in communication means that it would behoove us to have some public statement either in the charter or from the chairs or the AD saying, here's our plan about extensibility. If you are doing work that wants to do proxying over quick, here is how you play with this, and invite them in to not necessarily be the core documents, but to participate in the extensibility of it. That's my soapbox.
Thank you. Yeah, I think so. Interia had a couple of presentations about quick tunneling that made some things that looked a lot like Connect, and the discussion that's been happening since then is very much one of, now is a really good time to come and let's talk about use cases, and we're currently sorting out our own set of use cases and requirements, and that this is a propitious time for the folks presenting in Interia to join that discussion and have everyone talk about that together. Miria, do you have like 60 seconds? And then I've got a couple more things to talk about at the end.
Yeah, I take the 6 seconds. I just want to add on the extensibility point. I think like we've seen that's really important to have that ready. However, it's a little bit too easy to just say like we leave this for an extension later on. Because for example, for the ECN case, there are two different ways. There might be per packet information that you need, or more like ECN counters, which are more event-based signaling mechanism, whatever. So we also need to make sure that we have the right extensibility mechanisms in place. And for that, it does probably make sense to talk a little bit or think a little bit about the details more to ensure that we have the right extendability mechanisms.
Thank you, Martin.
Yeah, so somebody asked about the charter. I mean, I think the charter is not super specific about exactly what bits of UDP and IP proxying need to be in there, and I think that's fine. And I think it's premature to over-index over what's an extension, what's not, and how many physical drafts there are. By all means, like, let's figure out what we want to address in this. Let's get consensus on what we want to address in this take, and whether there's like technically an RFC that has like basic connect UDP, and then there's another RFC with a couple of extensions, or it's all just glommed into one draft is like an editorial matter. But I think we just have to reach group consensus on what's worth addressing in this take. I don't think the charter is particularly instructive there.
Yeah, I would agree with that. So I think we have some pretty clear things that we need to do. I think the first things are, let's go to the GitHub issues, file new ones for some of the things that came up as new issues today, and hop on some of the other ones or use the mailing list. Let's make sure that we try to focus on the use cases that we believe we really need to support and try to gain some agreement on that and the requirements that follow from that, more so than the particular solution that we want to deploy. And we'll also try to go schedule an interim so that we can get together and drive some of the resolution forwards on those issues. But in the meantime, let's try to see how far we can get the conversation there. If we can get to any concrete proposals, that would be really lovely. And with that, thank you all for some really excellent participation at the very end of the very last session of IETF 109.
I believe David has some parting words.
Thanks, everyone, and cheers to the universal deployment of Masque.
All right. Let's get some sleep.